Hi, my name is Brad Bullington. Welcome to CFI 308. We use this lab for our chemistry labs. And today I'm going to be showing you an example of a lab that we do with our chemistry honors, chemistry AB, and chemistry AC, the flame test lab. In front of you, you'll see some cards. Those cards are of fireworks displays that are similar to the ones you're going to see tonight. Those fireworks are charged with different metals. What we can do is we can identify those metals by taking solutions and passing them through a flame and exciting their electrons. And this is what's happening in the night sky when you see a fireworks display. So just by exciting their electrons, they rise to a higher energy state and drop to a lower energy state. When they drop, they have to give off that energy that they've absorbed, in this case from the heat. That energy is given off as light. So you see fireworks in the sky. So we're going to go through each of these, and I'd like for you to pair the flame color that you see here with the fireworks display on the cards in front of you. The first metal that we're going to see is calcium. So this is the flame color that is exhibited from excited calcium electrons. The next is lithium. This is the flame color that is exhibited from excited lithium electrons. Potassium. This one's very subtle. But it's a violet color. And this is the color exhibited from excited potassium electrons. The next is copper. Copper can emit really two colors. The first one that you see should be an emerald green. And then that may be followed up with a shade of blue or blue-green. Kind of looks like the patina that covers oxidized copper or the surface of a penny at the bottom of a wishing well. The next is sodium. Now be careful because this one's very similar to calcium. And finally, strontium. And if you want to see the metals that are in the other two containers, you'll have to enroll as a student. The second part of our flame test lab is a bright line emission spectrum lab. And you'll see that my colleague, Kevin Desrosiers, his students are going to be working on this today. And they're going to be taking a spectroscope and also a spectrometer where they're going to be analyzing the flame colors that are given off, or the colors of the gases that are excited in these tubes. So not only can metal elements be excited, but other non-metal elements can be excited as well. Here we have hydrogen. Hydrogen gives off a bright line spectrum, as you can see. And these bright lines are analyzed by the students with the spectroscope. And they correspond to the position of the electrons around the atom. Kevin's going to tell you about the next gas that we have, mercury.
So mercury, unlike hydrogen, gives off a blue color when it is excited. The students, when they go through and view this with their spectroscope, will see several more lines that are now given off, denoting that mercury's electrons are going into several different places as compared to hydrogen. These two different experiments, the flame test and the bright line spectrum, are different ways of analyzing what possible elements we could be working with. The flame test is a more simple take on it because some elements are going to burn similar colors. The bright line spectrum is very similar to like a fingerprint analysis for your different elements. When viewed through a spectroscope and then passed through a prism inside of it, each element is going to blend off, or not blend off, but divert off into different bands of colors, and we can use these bright line spectrums to figure out exactly which elements we are corresponding to. This is a simple version how we can analyze where different stars or planets, what things they are actually made of far off in space.
If you see us around tonight, don't be a stranger. Tell us if you engaged in the lab, and be ready for a pop quiz.